Now next topic is one function. One function or injective function. Now to understand this definition, taking example. Suppose I am taking a function whose domain is A and codomain is B. Domain and codomain, this is B. Domain contains, suppose numbers x1, x2, x3, x4. Codomain contains numbers, suppose y1, y2, y3, y4. Suppose image of x1 is y1. Here function is f. Image of x1 under f is y1. So y1 is image of x1. Image of x2 is y3. This is image of x2. Image of x3 is y2. This is image of x3. Image of x4 is y4. This is image of x4. See, observe in this domain. These are distinct. Their images are distinct. Distinct input, distinct output. For every pair of distinct input from domain, select any two distinct numbers and observe their images. Images are also distinct. So this function is said to be one function. It is one function. So putting here in words, let f from a to b be a function for every x1, x2 belonging to A, for every pair of elements belonging to domain. Always we take inputs from domain. For any pair of elements x1, x2 from domain, x1 is not equal to x2 implies fx1 not equal to fx2. See, x1, this is fx1, x2, this is fx2, this number is fx2. Image of x2 under f, this is image of x3 under f. So x1 not equal to x2, fx1 not equal to fx2. Distinct inputs, distinct outputs. If this is true, then for every x1, x2 belonging to A, this is true. Let me change here word. For every x1, x2 belonging to A, if this is satisfied, then this function is said to be a one function, or it is said to be injective function. Now, if function is not one, then what happens? That I am explaining. Suppose here this is A, this is B, x1, x2, x3, x4, domain, here codomain. Suppose image of x1 is y1, Image of x2 is y2. Image of x3 is also y3. Image of x3 is also y2. So this is also image of x3. Same number is also image of x3. y2 is image of x2 as well as image of x3. Image of x4 is y4. This is image of x4. So see here what is happening. In domain, there are two numbers which are distinct, but under F, their images are same, distinct input, but same output. Many, one. This is many, one. This function is many, one function. So it is many, one function. Means not one function. So if we can find x1 x2 belonging to domain such that x1 not equal to x2, x1 not equal to x2 implies but image of x1 equal to image of x2, image of x1 equal to image of x2. Inputs are distinct but outputs are same, so many, one. Then this function is said to be many, one, or it is not one function. So that is meaning of many one function, or when it is not one. Let me understand this by one example. Suppose f is from n to n, fx equal to x square. Let me check, is it 1 or not? Say here, if we put here any element, say domain is n. So from domain here, only natural numbers are allowed. So we can put here 1, we can put 2, we can put 3, we can continue. Image of 1 is 1, image of 2 is 4, image of 3 is 9. We can show this by diagram. See here I am showing by diagram, Venn diagram. See here, this is domain, this is codomain. Domain is n, codomain is n. Domain contains 1, 2, 3, 4, 5, etc. 1, 2, 3, 4, 5, 6, etc. Image of 1 is 1 square, image of 1 is 1, image of 2 is 4, image of 3 is 9, somewhere here there will be 9. So you can see that here image of 1 is 1, image of 2 is 4, image of 3 is 9, image of 4 is 16, image of 5 is 25, and so on. No any output is repeating. If output is repeating, then it is not 1. But for every distinct input, output is also every time distinct. Then it is 1. So here no repetition of output. So distinct input, distinct output. Select any two input. 3 not equal to 5, 9 not equal to 25. For any distinct input, outputs are also distinct. So here function is here x1 for every x1, x2 belonging to domain. What is domain? N. x1 not equal to x2 implies fx1 not equal to fx2. So this is 1 1. Therefore this function is 1 1. x1 not equal to x2, fx1 not equal to fx2. See, no repetition. If you get repetition, means images are equal. These are repetition of images, but here no repetition of value. So that means it is 1 1. Suppose if we take a function g, now I am changing a domain z and function I keep saying gx is x square. Now let me think about this function. Say here domain is z. Always we take input from domain. See, from domain I am selecting two values, 2 and -2. These are in domain. Not equal. Now let me check f of 2. F of 2 is 4 and f of -2 is also 4. Say 2 is not equal to -2. 2 is not equal to -2, but f of 2 is equal to f of -2. Image of 2 is 4. Image of 2 is 2 square, 4. Image of -2 is also 4. So under g of 2 is 4, g of -2 is also 4. 2 is not equal to -2, but their images are same, so it is many one. x1 not equal to x2, but fx1 equal to fx2. Repetition of output. Similarly, we can here take many examples. Image of 3 is 9, image of -3 is also 9. Image of 4 is 16, image of -4 is also 16. Domain is z, z includes negative integers, that why this is taken. Here any set of natural numbers, negatives are not included. So here negative input is not allowed. Take only positive inputs, positive integers. So that's why here no repetition, and here there are repetitions. So this function g is not 1 1 function, or it is not injective function. So that is meaning of 1 1 function. Now next topic is onto function. Onto function, or it is said to be surjective function. Now to explain this definition, I am taking a diagram. Suppose domain of a function is A, codomain is B. Let me take elements in domain x1, x2, x3, x4. Here I am taking y1, y2, y3, y4. Suppose that image of x1 is y1 under f. Image of x2 is y2. This is image of x1. This is image of x2. This is image of x3. And this is image of x4. Say here domain contains 4 numbers. Codomain contains y1, y2, y3, y4. You can see that every element of codomain. See, y1 is image of x1, y2 is image of x2, y3 is image of x4, y4 is image of x3. Every element of codomain is image of someone from domain. y1 is image of x1. So we say pre-image of y1 is x1, pre-image of y2 is x2, pre-image of y3 is x4, pre-image of y4 is x3. So pre-image of every element of codomain exists in domain. So this function is said to be onto function. Every element must be image. No one should be left in codomain. Every element of codomain must be image. Suppose if I take here suppose this set is A, this set is B. Another diagram. Suppose here I am taking elements x1, x2, x3, x4, y1, y2, y3. Image of x1 is y1, image of x2 is y2, image of x3 is also y2. This is also image of x3. It is also image of x3. Image of x4 is y3. This is image of x4. Suppose this is a function g. Now see, here codomain has three elements y1, y2, y3. Codomain contains y1, y2, y3, and every element of codomain is image of someone from domain. Pre-image of y1 is x1. There are two pre-images of y2. Pre-images of y2 are x2 and x3. Two pre-images. Pre-image of y3 is x4. That means every element of codomain is image of someone from domain. So this function g is also onto. If I keep here function f, then this function f is onto. So in short, words we can put by this way, that f from a to b be a function if for every element y from codomain, these are y, every element of y from codomain, there exists its a pre-image in domain such that y is image of x under f. For every y belonging to codomain, there exists x in A such that y is image of x under f. If this condition is satisfied, then this function is said to be onto function or subjective function. Onto function or subjective function. Say here in these examples, codomain contains 4 numbers and range also contains 4 numbers. Here codomain is y1, y2, y3, y4. This is codomain. Range is also y1, y2, y3, y4. All elements are images. So set of images, these all are images. Set of images is said to be range. So range is codomain. In this example, range is codomain. Similarly here, say codomain is B. Codomain is B and B is set containing these three values. Range means set of images. So these are images. That means these are values of images. Range is same. So codomain and range are equal. Range equal to codomain. So when every element of codomain, if there exists input in domain such that every element of Y is image of some X under F, then that means it happens only when range and codomain are equal. Range equal to codomain. Every element of codomain is image. So this word is very important. Every element of codomain is image. That means range equal to codomain. So this definition can also be written in other words that, say here, this can be written in other words. If range equal to codomain, if range equal to codomain, then function is said to be onto function or surjective function. Now see, this function is 1 1 and onto both. This function is onto but not 1 1. It is many 1. So this function is many 1 means this is not 1 1 but onto. This is 1 1 and onto both. So remember this difference between 1 1 and onto function. Now let me explain when function is not 1 1. So not 1 1, then what happens? Explaining by diagram. Suppose here this is domain, this is codomain. Domain contains x1, x2, x3, x4. Codomain contains y1, y2, y3, y4. See, image of x1 is y1. Image of x2 is y2. Suppose this function is g. Image of x3 is y3. Image of x4 is also y3. These are images. This is many 1 function. It is not 1 1. But look here. y4 is not image of anyone. There does not exist pre-image of y4. So this is not onto function. See, which are words in definition? For every y belonging to codomain, if there exists x in domain such that y is image of x, then function is onto. So here for this y there exists x, for this y there exists x, for this y there exists x, for this y there exists two inputs x, but For this y, there does not exist x in domain whose image is this number y. So here this every is not satisfied. Something is left in codomain. So this is not onto. So here in this diagram there does not exist pre-image of y4 in domain. So G is not an onto function, or same thing we can say by this word, using these words, that here codomain of function G. What is codomain? y1, y2, y3, y4. B is codomain. It is B. This is B. It is y1, y2, y3, y4. This is codomain. Codomain means set of all numbers in second set. Means second set whole second set is codomain. This is domain, this is codomain. So codomain is y1, y2, y3, y4. What is range? Range of G is, say, range of this function means set of outputs only, set of images. This is not image. These are images, y1, y2, y3. And you can see that range is not equal to codomain. So here range is not equal to codomain. So this function G is not onto function. So that means we can say that if for any function f from a to b, for any function f from a to b, if we can find y, if there exists y in B such that, if we can find such number y in B such that y is not image of any x, if we can find y in B such that y is not equal to fx, or we can say if we can find y belongs to B for which there does not exist x in A such that y equal to fx. Same thing in different way. If we can find y belongs to B for which there does not exist x in A such that y is image of x, then this function is not onto function. Function is not said to be onto. So this is meaning of onto function or surjective function. Then one more word, bijective function. If any function is 1, 1 and onto both, or injective and surjective both, then it is said to be bijective function. If any function is injective and surjective both, then it is said to be bijective function. That means if function is 1 1 and onto both, then it is bijective function. Now to check the injectivity and the surjectivity, means are given functions 1 1 or not, are onto or not, that we are asked to check in these questions. So here a function is from n to n, f of x is equal to x square. Say here, if you say domain is n, so if we keep 1, then image of 1 is 1 square. Say image of 1 is 1 square, that is 1. Image of 2 is 2 square, that is 4. If we keep 3, image of 3 is 3 square, that is 9. If we keep 4, image of 4 is 16. You can see that distinct outputs, distinct inputs, distinct outputs. So by observation it is clear that this function is 1 1. You can understand by diagram also that this is domain, domain is n, codomain is n. Here 1 2 3 4 5 etc. Here 1 2 3 4 5 6 7 8 9 10 etc. Image of 1 is 1, image of 2 is 4, image of 3 is 9. Similarly, image of 4 is 16, somewhere here. So no repetition of output, no repetition of image. Distinct input, distinct output, distinct input, distinct output, distinct input, distinct output. x1 not equal to x2 implies fx1 not equal to fx2. Now see, when we discussed definition of one-oneness, in that definition, say f from a to b be a function for x1 x2, for x1 x2 belonging to a, x1 not equal to x2 implies fx1 not equal to fx2. If this condition is satisfied, then function is 1 1. Already we discussed this definition. Now this statement we can express by this condition, we can put by another method. See, I am writing this condition by different method. For x1 x2, for x1 x2 belonging to a, if, now here this I will replace by different method, then function is 1 1. See, when doing a mathematical reasoning in class 11, we discussed about implication. P implies Q. If any statement is given in this form, P implies Q, then its logical equivalent statement is not Q implies not P. P implies Q, not Q implies not P are logically equivalent statements. Their meaning is same. So if this is P, P implies Q. So now I am putting here not Q implies not P. P implies Q. Now if this is Q, then not Q is fx1 equal to fx2. This was P. So not P is x1 equal to x2. So now remember that x1 not equal to x2 implies fx1 not equal to fx2. Its logical equivalent statement is fx1 equal to fx2 implies x1 equal to x2. So instead of showing this condition, if we can show this condition, if we can prove this condition for any function, then it is 1 1. Meaning of these two are same. So here x1 not equal to x2, fx1 not equal to fx2, x1 not equal to x2, fx1 not equal to fx2. So here we can see this is satisfied. But here we are putting in words using this definition. Second form we are going to use for x1, x2 belonging to A. What is A here? N. For x1, x2 belonging to domain, we are beginning from fx1 equal to fx2. fx1 equal to fx2. Beginning from fx1 equal to fx2, we have to show that x1 equal to x2. So now, beginning from fx1 equal to fx2, see now, what is fx1? fx1 is x1 square. What is f of x2? f of x2 is x2 square. So x1 square equal to x2 square. But x1 and x2 are natural numbers, so this means x1 equal to x2. Here we cannot keep x1 equal to plus minus x2 because already both are taken from natural numbers. So therefore fx1 beginning from fx1 equal to fx2, we have shown that x1 equal to x2, so function is 1 1. Therefore this function is 1 1. So therefore fx1 equal to fx2 implies x1 equal to x2, so function is 1 1. Or we can say this function is injective. It is 1 1 or injective. Now, so remember, whenever function is 1 1, when solving the questions, if you see by observation that function is 1 1, then answer for 1 1ness in words we shall write by this method, means using this definition. Using this definition we will show function is 1 1 by this way. This is the method if function is 1 1 to show on paper. Now on to next. See again, in the beginning I discussed image of 1. Image of 1 is 1. Image of 2 is 4. Image of 3 is 9, etc. So what is range here? Range is 1, 4, 9, etc. So range contains perfect square numbers. And what is codomain? Codomain is n. Range is not equal to codomain. Range is not equal to codomain. And when range is not equal to codomain, then function is not onto function, or it is not surjective, or it is not surjective. Function is not onto function because range is not equal to codomain. Say 2 is not image of anyone, 3 is not image of anyone, 5 is not image of anyone. So there are so many y's for which there is no x in domain such that y is image of x. Many numbers are left without connection. So if it happens, function is not onto function. So when this happens, range is not equal to codomain. Range is not equal to codomain, function is not onto function, or it is not surjective function. Now in this question, say domain is R. R contains all real numbers. Here domain was N contains only natural numbers. So we have discussed about only natural inputs. Any function will accept. Function is one type of machine. It will accept only elements from domain. Whatever is domain, those numbers we are allowed to put in machine. If anything is not in domain, we are not allowed to put here. So because here it is natural numbers, we are allowed to put here only naturals. But here domain is R. So we can put here any real, positive, negative, fractional, non-fractional, integer, rational, irrational, any number is allowed here. Now first of all we check injectivity. Say here R contains 2. I am putting here 2. Put any number. Suppose I am putting 5. F of 5 is 25. And if we keep minus 5, minus 5 is also in R. Here we can't take minus 5 because minus 5 is not in domain. So f of minus 5 is 25. See what is happening? Image of 5 is 25 and image of minus 5 is also 25. Many 1. Here 5 is not equal to minus 5. x1 not equal to x2, but f of x1 equal to f of x2. So this function is not injective, or it is not 1 function. This is a many one. x1 not equal to x2 implies f x1 equal to f x2. Many 1 or not 1 or not injective. Now for surjectivity, let me check its range. See here, because domain was N, after 1, beginning is always from 1. After 1, next immediate is 2. After 2, next immediate is 3. Between 2 and 3, nothing is there in N. So after 2, next is only 3. We can't put here 2.5, 2.6. But here, domain is R. So we can put 2, we can put 2.1, we can put 2.2, we can put 2.7, 2.007. All reals are allowed, and we have to think all outputs for all reals. So see, this is the way. Here, for every x belonging to R, if x is any real number, put here any real, whether it is positive or negative. This will be square of this number. Function calculates square. So its a square is always positive, always greater than or equal to 0. Square is always greater than or equal to 0. That means fx is greater than or equal to 0. That is fx belongs to close interval 0 to infinity. And set of fx, that is range. This is the range. Values of images are greater than or equal to 0 means set of fx is close interval 0 to infinity. So range is close interval 0 to infinity. And what is codomain? Codomain is R. This is not R. Range is not equal to codomain. So this function is not onto or not surjective function. Now in this question, say here f z to z, it calculates cube. If you imagine for distinct inputs, their outputs, then image of, say here z, here z, image of 1 is 1 cube, image of minus 1 is minus 1. If you keep minus 1, output is minus 1. If you keep 2, output is 8. If you keep minus 2, output is minus 8. If you keep 3, output is 9. If you keep minus 3, output is minus 27. Sorry, here it calculates cube. If you keep 3, it calculates 27. If you keep minus 3, it calculates minus 27. 3 cube is 27, minus 3 cube is minus 27, 2 cube is 8, minus 2 cube is minus 8. See here, you will not find any repetition. Nowhere repetition. Distinct input, distinct output. Image of 0 is 0. Domain is Z. So think about all integers. Codomain is Z. Outputs are integers. So distinct input, distinct output. So this is a 1-1 function. So because this is 1-1 function, 1-1ness we are showing by this method. For x1, x2 belonging to domain Z, this is domain. What is it? Domain. Here this n was for domain. For x1, x2 belonging to domain, suppose that fx1 equal to fx2. fx1 equal to fx2. Whenever any function is 1-1, to show 1-1ness on paper, in maximum sums we perform this method. Second form of definition. fx1 equal to fx2, start from fx1 equal to fx2, prove that x1 equal to x2, then function is 1-1. So beginning from fx1 equal to fx2 and going to prove that x1 equal to x2. So beginning from fx1 equal to fx2, fx1 is x1 cube, fx2 is x2 cube. Now x1 cube is x2 cube, so obviously x1 equal to x2, because these are integers. If here square is given, suppose x1 square equal to x2 square, and if I put x1 equal to x2, then this will be wrong, because these numbers are from Z. So because these numbers are from Z, x1 square equal to x2 square, it does not mean x1 equal to x2. 2 square equal to minus 2 square, it does not mean that 2 equal to minus 2. Compare with this statement. x1 square equal to x2 square, this is true, but this is not true. x1 square equal to x2 square implies x1 equal to x2 is not true. Why? When it is, it will be not true. If these numbers are taken from Z, because Z contains integers, negative also, it includes negative also. But in this question, because these were natural numbers, that's why this was true. So in this question, if here Z to Z is given, then we are not allowed to put x1 equal to x2. This is the reason. But here in formula, cube is given. Because cube is given, it is allowed. Here cube is given, x1 cube equal to x2 cube, so x1 equal to x2. Therefore, fx1 equal to fx2 implies x1 equal to x2. So function is injective or It is 1 1 function. Now for ontoness, let me check codomain and range. Say here, this is domain. In domain, there is 0, -1, -2, 1, 2. These numbers are in domain. If we keep -2, f of -2 is -8, f of -1 is -1, f of 0 is 0, f of 1 is 1, f of 2 is 8. Just discussed. F of 3 is 27. Continuing this way. These are outputs. See, I am taking every input from domain 0, 1, 2, 3, 4, 5, -1, -2, -3, -4 to be continued from both sides. These are all outputs in sequence. So from this, what we can say, that range is equal to, it is set of all perfect cube numbers -8, -1, comma 0, comma 1. Here I want space. Comma 8, comma 27. This is range. It does not include all integers. So many integers in codomain are left which are not images. So here range is not equal to, range is not equal to Z. So range is not equal to codomain. Range includes these integers. Codomain includes all integers. So range is not equal to codomain. So function is not surjective. This function is not surjective. Image of 1 is 1. Sorry, pre-image of 1 is 1. Pre-image of 8 is 2. But there is no pre-image of 9. No pre-image of 10. No pre-image of 11. Till 26, we don't have pre-image. Then next, pre-image of 27 exists. Then we don't have pre-image of 28, pre-image of 29. So pre-image of only perfect cube numbers from codomain exist. So that's why this function is not surjective. Prove that the greatest integer function f from R to R given by fx equal to box x is neither 1 1 nor onto, where box x denotes the greatest integer less than or equal to x. Greatest integer less than or equal to x. Say here f is from R to R and fx equal to box x, where box x denotes greatest integer less than or equal to x. See, before taking this question, once again I revise about this greatest integer function. Say here function is f from R to R, fx equal to box x. Say here domain, I am showing here domain. Suppose domain is -1, 0, 1, 2, 3, like this. This is domain. If I take value, suppose I am taking 2.7. Somewhere here, suppose I am taking 2.5. So image of 2.5. Image of 2.5 is box value of 2.5. Now, box value of 2.5, what it denotes? Greatest integer less than or equal to x. say greatest integer less than 2.5. What is greatest integer less than 2.5? So that means look on left side and take left side first integer. F of 2.5 is 2. If you take 2.7, this is 2.7, f of 2.7, so box value of 2.7, so box value of 2.7 is greatest integer less than or equal to 2.7, greatest integer less than 2.7. so take first integer on left. So 2 is the greatest integer less than 2.7. So its value is also 2. So you can see that these images are distinct but outputs are same. If you take integer 2 itself, if you take 2, if we keep here 2, then box value of 2, box value of 2 denotes greatest integer less than or equal to 2. So greatest integer less than or equal to 2. Now 2 is integer. If you take integer, then integer itself is output. If input is integer, keep integer as it is. If given number, taken number is not integer, then take left side first integer. So here you can see that, say here it is clear 2 is not equal to 2.5. 2 is not equal to 2.5, but f of 2 is equal to 2. F of 2.5 is box value of 2.5 is also 2. So 2 and 2.5 are not equal. X1 not equal to X2, but fx1 equal to f of x2. X1 not equal to x2, but f of x1 equal to f of x2. Image of 2 is also 2. Image of 2 is 2. Image of 2.5 is also 2. Image of 2.7 is also 2. There are many numbers, infinite numbers whose image is 2. So x1 not equal to x2, but fx1 equal to fx2. Therefore, this function is not 1 1 function. If function is not 1 1, then give counter example. Show pair of numbers from domain, distinct numbers whose images is same. Now we check ontoness. Say here what is happening. Image of 2 is 2. Image of these all numbers. If I take 2.999, box value of 2.999, this is not integer. So take left side first integer. So what is left side first integer? It is 2. 2.999 is somewhere here. It is not integer, so take left side first integer. That means if you take numbers from this part, if x belongs to close to open 3, why open 3? Because if you take 3, then box value of 3 is, say, box value of integer is itself. So now as 3 starts, images are new. For these numbers, image is 3. For these numbers, image is 2. So that's why we do not include here 3. Image of 2 is 2. Image of 2.1 is 2. Image of, take any number from this set. 2, 2.1, 2.2, 2.3, 2.5, keep in machine. Their images is 2. and numbers beginning from 3, if you take numbers from 3 to 4, now keep here 4 open. If X is in this set, then its image will be 3. Here image will be 2. Similarly, if you take from this interval -1 to 0, image of -0.7, -0.7 is somewhere here. So image of -0.7, that is box value of -0.7, -0.7 somewhere here. Now it is not integer. What is left side first integer? It is -1. It is not like that whatever you keep, output is the integer which is on left of decimal point. So here left of decimal point is 2, so output is 2. Left of decimal point is 2, so output is 2. But not always like that. If this number is positive, then if you feel like that. But since number is negative, here on left to decimal point is 0, but output is not 0. What is mathematics? Observe number line. If taken number is not integer, then take integer which is on the left side of that number. So take integer from left side of that number, from number line, not from decimal point. Take from number line. So box value of -0.7 is -1. So here if you take numbers from this interval from -1 to 0, if X is in this set, then box value of these all numbers is -1. So now this I am putting here properly. This is codomain. This is domain. Say this is domain. -1, 0, 1, 2, 3, 4, etc. Say if X is from closed interval -1 to 0, then images are -1. If X is from 0 to 1, then images are 0. If X is from 1 to 2, close 1, open 2, then images are 1. If X is from 2 to 3, then images are 2. See, left side I keep closed, right side I keep open. So this can be continued. So if you select any number from set of real numbers, this is domain, select any real, outputs are only integers, and we are getting all integers. So therefore here range is equal to -1, 0, 1, 2, 3 and so on. Range is Z. And what is codomain? Codomain is R. So Z is not R. R is codomain. This is codomain. So range is not equal to codomain. So this function is not onto function. So given function is neither 1, 1 nor onto. Therefore, given function is neither 1, 1 nor onto. Now next question. In each of the following case, check whether function is 1, 1, onto or bijective. Say here function is from R to R, defined by fx equal to 3 minus 4x. Now keep remember one point. If f is from R to R and it's a linear function, say this is linear function, it is like ax plus b, f from R to R, fx equal to ax plus b, where a is non-zero, so this is a linear function, and every linear function defined from R to R is always 1 1 and onto. So this is always 1 1 and onto both. So if you are asked as a multiple choice type question, and if you are given R to R ax plus b, then such type of functions are always 1 1 function. So ax plus b means 3x plus 4, 4x plus 5, 6x minus 8. A and b are any real, a is non-zero. So all such functions are 1 1 and onto. Now in subjective part, how to show, how to write steps that it is 1 1, how to show 1 1ness and onto-ness. For 1 1ness, here first part for 1 1ness, for every x1 x2 belonging to domain, this is domain, for every x1 x2 belonging to domain, we start from fx1 equal to fx2. For every x1 x2 belonging to domain, suppose that fx1 equal to fx2, and we are going to show x1 equal to x2. fx1 is 3 minus 4x1. f of x2 is 3 minus 4x2. 3 minus 4x1, 3 minus 4x2. So minus 4x1 equal to minus 4x2. So x1 equal to x2. This 3 3's cancel. So therefore fx1 equal to fx2 implies x1 equal to x2. So function is 1 1 function. Therefore this function is 1 1 function. Whenever function is 1 1, we use this second definition, second form of definition. fx1 equal to fx2 implies x1 equal to x2. Function is 1 1. Now for onto-ness. For onto-ness, we shall prove that for every y belonging to b, b means codomain, if there exists x belonging to a such that y is image of x under f, then this function is said to be onto function. These were words in definition of onto function. For every y belonging to codomain, if there exists something, means pre-image in domain whose image under f is y, then we say function is onto. So we apply this method in showing onto-ness. Now for onto-ness, for every y belonging to b, for every y belonging to b, what is b here? R. This is codomain. B means codomain. For every y belonging to b, we suppose that y equal to fx. We are supposing. Suppose that y equal to fx. Here first of all we shall suppose that y is image of x under f, And what we want to derive? We want now existence of x in A. If x exists, there exists x in A, then these words are satisfied. So let me check existence of x in A. So in this procedure, this is A, this is B, we have taken y, and we have supposed that y is image of some x. Now we want this pre-image. This pre-image we need in domain. If it is in domain, then function is onto. If pre-image is not in domain, outside domain, it is not onto. So now we are checking whether x belongs to domain or it does not belong to domain. Any one possibility. So we suppose that y equal to fx. So method is, for start from these words, for every y belonging to codomain, suppose that y is image of x under f. Now we want to know about x. From this we calculate x. So y is equal to, now what is fx? Fx is 3 minus 4x. We are interested in knowing about x. So find out x. So 4x is 3 minus y. So x is 3 minus y upon 4. Now see, y is real. This number is real. 3 is also real. 3 minus any real is a new real. Divide by 4. So again we are getting new real. So whatever will be its value, it belongs to R. X belongs to R. This is domain. This R is domain. So we prove that yes, there exists x in A. Started from this point. Suppose that y equal to fx. And we wanted to check existence of x in domain. So yes, x belongs to domain. Now let me verify. Is image of this x. So here we have taken y from codomain, and here we have found x. X in codomain. What was value of x? 3 minus y by 4. This is x. X in domain. It was value of x. It is value of x. X is 3 minus y by 4. Existence is verified. Now we verify that now this value we are putting in machine, and we are verifying that is image of this number is y. So for this number, for which, for this number we find f of x. So f of x is, f of x means f of 3 minus y by 4. I have taken value in this expression. I have taken here x equal to y by 3 minus y by 4. X is 3 minus y by 4. So beginning from fx, put x equal to 3 minus y by 4. Now f of 3 minus y by 4. So putting here 3 minus y by 4. Same value I am putting here. So f of 3 minus y by 4 is 3 minus 4 into 3 minus y by 4. This value I am putting in this machine. Same number I am putting here. So this is equal to here 3 minus 3 plus y. So y is obtained. So image of this number is y. Yes, image of this number under f is y. So what we have proved, therefore for every y belonging to R means codomain, there exists X in domain. There exists X in domain such that this Y is image of X. So therefore this function is onto function. So given function is 1 1 as well as onto. So function is 1 1 and onto, therefore it is bijective function. This function is bijective. So remember this key point. Every such type of function is always 1 1 and onto. Now in this question, function is from R to R, fx is 1 plus x square. We want to check 1-1ness and onto-ness. Say formula includes x square. So whenever you get x square, then you should get immediately idea that it may not be 1 1. If domain is R or Z, say domain is R. From R, suppose I am taking here, I am putting value 3. If I keep here 3, so image of 3 is 1 plus 9, so it is 10. And I am putting minus 3. If I keep here minus 3, then also value is 10. So what you can see, image of 3 is 10, image of minus 3 is also 10. 3 is not equal to minus 3, but their images are equal. See these numbers, x1 not equal to x2, both are taken from R. If domain is R, then here negative is allowed. Domain is Z, negative is allowed. But if n, then don't take negative. You have to take only positive integers if domain n is given. In that case, this will be 1 1. But because of R, here we can take any numbers. So x1 not equal to x2, but fx1 equal to fx2. Therefore, this function is not 1 1 function, or it is not injective function. Now for onto-ness. So for onto-ness, here if we take any real for every x belonging to R, R is domain. If we take any real from domain, let me check nature of its image, which type of images we are getting. So if x is any real, then observe this formula. If x is any real, x square is always greater than or equal to 0. X square is always greater than or equal to 0. Now I am adding 1. So 1 plus x square is greater than or equal to 0. See, this is fx. Here, develop these terms as per question. So fx is, here adding 1, sorry I did here mistake, adding 1, this will be 1. Both sides 1 is added. So now this is fx. So f of x is more than or equal to 1. That means fx belongs to close interval 1 to infinity. So range is equal to close interval 1 to infinity, and range is not equal to codomain. See, this is codomain. Range is not equal to codomain. Range is not equal to codomain. Therefore, this function, therefore this function is not onto function. So function is neither 1 1 nor onto, so it is not bijective. So here a domain is R, codomain is R, and range is 1 to infinity. If this is 1, this is range. Range is always subset of codomain. That is always true. Range is subset of codomain. Range is set of all images. So if you select any number more than 1, then its pre-image exists. If you select any number from this part, if this is y, then its pre-image x, here, yes, it exists. But if you select any number y which is less than 1, if you select this number y which is less than 1, then its pre-image x does not exist. There is no x whose image is 0.1 or its image is -1. For any y less than 1, no pre-image. That is the meaning of range. Let A and B be sets. Show that function from A cross B to B cross A such that f of AB is equal to BA. Show that this function is bijective function. See here, to understand this I am taking one simple diagram. Domain is A cross B, codomain is B cross A. See, meaning of this formula is that f of EB is BA. Means if you keep 1 2 in this machine, f of 1 2 is 2 1. This is image of 1 2. F of 1 2 is 2 1. This is f of 1 2. If you put here, suppose -2 3. So f of -2 3 is 3 minus 2. This is f of -2 3. So f of EB, when you keep this element AB in machine, it converts into BA. In short, if you put here xy, image of xy is yx. If you put here x1 y1, then output is y1 x1. If you put x2 y2, then its image is y2 x2. In short, if you keep here xy, its image is yx. So from this observation, by this observation we can see, obviously this will be 1 1, it will be onto. See, let me put in words. For one oneness, first part for one oneness, for every x1 x2 belonging to domain, here domain is Cartesian product. Because it is Cartesian product, elements are of this pattern. It contains ordered pairs. So take these two distinct inputs. So for every x1 xy1, x2 y2 belonging to domain, we suppose that f of x1 y1 equal to f of x2 y2. x1 y1 x1 x2 x1 x2 belonging to domain. Suppose that f of x1 equal to f of x2, like that. So we are taking pattern of elements as per domain. Domain is Cartesian product, so elements are ordered pairs. So take two elements from domain. So these two elements are taken from domain. Suppose f of x1 y1 equal to f of x2 y2. So we are going to show that it is equal to x1 y1 equal to x2 y2. Applying second form of definition of 1-1 function. Now see, f of x1 y1. So f of x1 y1 is y1 x1. f of x2 y2. f of x2 y2 is y2 x2. This means y1 equal to y2 and x1 equal to x2. This means x1 equal to x2. Same statement. y1 equal to y2. That means x1 y1 equal to x2 y2. So now match with words of definition. For x1 x2 belonging to domain, f of x1 equal to f of x2 implies x1 equal to x2. So therefore this function is 1-1 function. Now for ontoness. For ontoness, what we do? Every element of codomain. For every y belonging to codomain, we need x in domain. Every element of codomain must be image of someone. So that we show by this way. For every element, let me say yx. For every yx belonging to B cross A, this is codomain. For every yx belonging to codomain, there exists. It's a pre-image xy in domain such that image of that element from codomain is image of xy. So you can find its matching with a statement we discussed in definition. For every y belonging to codomain, there exists x in domain such that y equal to fx. For every y belonging to codomain, there exists x in domain such that y equal to fx. So this function is onto function. So function is 1-1 and onto both. Therefore, function is 1-1 and onto both. Therefore, it is bijective function. This diagram is to understand. It is not required in examination. Let f from n to n be defined by f of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even. So that state whether function f is bijective. Justify your answer. Say here we understand the procedure. Domain is n. So only natural numbers are allowed to keep in this machine. If I keep 1, putting here 1 is odd, so put here 1. So 1 plus 1 by 2. So 2 by 2 is 1. Now we keep 2. 2 is even. So put here 2. So 2 by 2 is 1. Then we keep 3. 3. Put here 3. 3 plus 1 by 2. 4 by 2. 4 by 2 is 2. Keep 4. 4 is even. So in this formula. Odd numbers in this formula, even numbers in this formula. So 4 by 2, that is 2. If we keep 4, keep 5. 5 is odd. 5 plus 1 by 2. 6 by 2, that is 3. If we keep 6, 6 is even. So 6 by 2 is 3. If you keep 7, 7 is odd. So 7 plus 1 by 2, that is 4. If we keep 8, 8 by 2 is 4. So we can continue this procedure. Now see, from this practical we can determine whether it is 1 1 or not, it is onto or not. See, you can see that image of 1 is 1, image of 2 is also 1. Here function is from n to n, f of n is equal to n plus 1 by 2 if n is odd, and n by 2 if n is even, n belonging to n. This is a function. Now here we have discussed that f of 1 is 1, f of 1 is 1, and f of 2 is also 1. Image of 1 is 1, image of 2 is also 1. So that means many 1. So here 1 is not equal to 2, but f of 1 is equal to f of 2. So this function is not 1 1, or it is not injective. The statement we have written for 1 and 2. Similar statement you can also put for 3 and 4. Similar statement you can also keep for 5 and 6. There are so many examples to show function is not 1 1, but show only any one counter example. Now let me check ontoness. Say here, if you say ontoness, here we can put this in simple way. F of 1 is 1, f of 2 is 1. Say for ontoness, we use here a definition of ontoness. This is domain, this is codomain. In codomain, these are numbers. When we can say function is onto, for every y belonging to n, if we can find its pre-image in n. In practical discussion it is clear that every element of codomain has its pre-image in domain. Every element has two pre-images. Every element has two pre-images. One is image of 1 and 2. 2 is image of 3 and 4. 3 is image of 5 and 6. 4 is images of 7 and 8. 5 is image of 9 and 10. Now see, focus on this number. 1 is image of 2. Sorry, pre-image of 1 is 2. Pre-image of 2 is 4. Pre-image of 3 is 6. Pre-image of 4 is 8. Pre-image of 5 is 10. So pre-image of y, you can see I have So you double 5 into 2 10, 4 into 2 8, 3 into 2 6. So if here number selected is y, then y is image of 2y. Y, this is 2y, y, this is 2y. So this is true for every element of codomain. Every element y of codomain, there exists x. What is this? Is our x. This is value of x. So take x equal to 2y, whose image is y. So using a terminology of definition statement, we are putting by this way that for every y belonging to n, this is codomain. For every y belonging to codomain, there exists x in domain. What is x? 2y. So there exists x equal to 2y in domain. So we have focused only on this part. This is y, this is 2y, this is y, this is x, this is y, this is x. What is x? It is double of y. So x is double of y. So there exists x double of y such that y is image of x under f. So therefore this function is onto function. So here function is 1 1, function is not 1 1, but it is onto. So because it is not both, this is not bijective. Therefore function is not bijective.